Most of the time, they can tell you to use any language you want.
Sorry. Yeah. Algorithm code.
Yes.
I don't understand. Are they the same? Are you explaining the same thing?
Yes.
So you can use. Is it that algorithm is another word for code in this context?
So an algorithm is a defined set of steps to follow. So you just need to know some of the different possibilities of them and like what would make my code like what about the hardware makes my code faster. And there are three major things. So the first one is CPU, which I'm sure we've all heard about.
Central processing.
So if you're
welcome back everyone to the Girl in My STEM Careers Limited show. My name is Faith, your host. Today we're going to be geeking about backend engineering with a senior engineer, Pascal Oba. Hi Pascal.
Hello Faith.
How are you doing?
I'm good. How are you?
We're about to find out. Please introduce yourself.
Okay, my name is Pascal Oba. I am a software engineer. I have been coding for 9 years, so since 2018. And I mostly do security, CDN infrastructure now, but I've done a lot of fintech as well, some blockchain stuff, so many things we'll get into, but yeah, that's what I do.
Nice. Security, I'm writing because all these things that you are saying is going to be leading very important to our conversation.
Yeah.
Okay, so I like the fact that you said you do security, fintech, and FDN infrastructure. So that means, first of all, I don't know, where do we want to take this? I don't want to go the normal route of what is backend engineering.
Yep.
But what's the difference between working in backend in security, fintech? I'm guessing that those are different experiences.
Yep.
Security, fintech, and what's the third thing?
I said I worked for a blockchain company as well. But what I said was CDN. So CDN.
You will say that in like 10 times.
Okay.
Okay. So what's the difference between working at backend, blockchain, CDN, fintech, and security?
Yeah. So that's a good question. So CDN stands for Content Delivery Networks. Okay. And what that means is, so let's imagine you want to watch a Netflix movie.
Yeah.
And you're in Nigeria.
Yeah.
And the Netflix movie is hosted somewhere in the US.
Yes.
When you click like watch, so let's say you want to watch Game of Thrones or Game of Thrones on Netflix, but you want to watch anything on Netflix, then your request will travel all the way through the Atlantic Ocean, whatever, go all the way to the US.
Yeah.
The US is going to respond with the video of the movie you want to watch.
Okay.
Imagine doing that with text like WhatsApp is much more faster because text is lightweight. But when you want to do it with videos, it's way more intense and expensive because videos are heavier than text.
Yeah.
So very big companies that want their customers to experience, especially like global companies, they pay CDNs to situate those videos close to home. So for example, a CDN company would have a data center in Lagos.
Okay.
So when you click watch this movie from Nigeria, it goes to Lagos. So nobody's watching Netflix going from the US. Even if that's where the company is based, they use CDNs to then distribute all their movies to different locations all around the world so that you watch those movies from where you're closest to, if that makes sense.
Okay, so that's content
delivery network. Yes.
Okay, so if I understand what you are saying correctly, I'm thinking in data farms, but this is not a data farm. This is, let's say, a digital farm or a digital space where it exists there and people can pick it up from there. You don't have to travel all the way to US.
Yes.
But it's not like a physical thing. It's an internet infrastructure.
Yes.
Okay.
So yeah, think of it like Amazon, but for the internet. So you want to order stuff, but Amazon just puts a warehouse close to you. So delivery, you pay for Prime, it happens fast.
Oh.
So, but this is a physical thing. So there's a data center that actually exists that they've built in Lagos State. And then those movies are kept in that data center.
Okay.
And then your movies are being fetched from there, basically.
Okay, so a physical space.
Yes. Yes, so basically the way it works is any site you visit is hosted somewhere. So when the someone says I pay for hosting or I want to host my website, what that actually means is I want to put it on someone's data center infrastructure that has 24/7 guaranteed light. Okay. You don't have any power outages. Basically, you could host your website on your laptop.
Yeah.
But one day you close your laptop, or one day you restart your laptop. So a data center is your laptop, but running forever.
Okay.
So people have those things in different countries, and you pay for it. So if you do fataloho.com today, you want to host it, you're going to pay who go host or whoever whatever, let's say a Nigerian company, what they do is they just have your laptop but running forever. You're paying them for doing that. Do you see?
Okay.
Yes.
Oh, that makes sense. There are plenty questions that are in my head, but before we start going to beyond that, let's come back to backend, to basics of backend.
Yes.
So in that transaction, what do you then do as a backend engineer?
Okay, so that's a very good question. So an easy way, even if it's more complex than that, so imagine where the backend starts from is from the location or from the exact point where the customer can't see anymore.
Okay.
So you open netflix.com, you see something. That's client side. That's what the front end person is doing.
Yeah.
From the moment you click watch, you don't know what happens behind that. So which is why it's called backend. It's basically not client facing.
Yeah.
So what happens, I think the first entry point to say there's a front end, there's a back end, is something called an API, which is like an application programmable interface. But basically, what it means is after you click, I want to watch this movie, that request goes from your TV, your phone, your laptop. So whatever is running on your TV, your phone, your laptop is the front end. That's the client side.
Yeah.
Goes to the company's back-end infrastructure to say, so what the back-end code is doing is, has this user paid? So if Netflix tells you, sorry, you've not paid for this service, you don't have access, is the backend doing that? So we do like authentication. Has Faith paid for this service? Does she have like the rights to watch this service? Like with something like Netflix, for example, you have like rights for the movie, or are you in the right location to watch it? And then all of that logic is happening in the backend. And then going to the database or the data store, wherever we store these movies, to fetch the movies and then show it to you, is what the backend is doing. So the backend and the front end are like communicating with each other, saying like, show this part of the movie to this person, if that makes sense.
Okay. All right. That makes sense. So bring me back to the very, very genesis of backend engineering. What is backend engineering?
Good. So as I said, the backend engineer is doing everything after what the client sees.
Okay.
And basically, I would say it is as close to what the business logic is for the company. So let's say you're a fintech company.
Okay.
Basically, what you'll be doing is like debits and credits and like handling records and like past transactions for people. All of that business logic, where it's actually happening, lives in a particular code base where it is hosted. So that is what the backend engineer is doing. The front end person is then calling whatever interface the backend person makes available to the front end. And then if you like click, I want to pay, whatever interface, yes, is what the front end person is doing. But what's actually happening when you click that behind the scenes is what the backend engineer is doing. So I think the major thing I would say is it is divided into three parts, sort of.
Okay.
So firstly, there's the programming language you want to use to write your backend code.
Yeah.
When I started coding, and I mean, even till now, the most popular one maybe would be like Node.js. That's what it's called. So Node JavaScript.
Okay.
And then you use that to write the actual code where you do all the validation, you do the authentication, you fetch the data. All of that happens with a language. It can be any language. The second thing would be the operating system is running on. So the operating system, for example, when you're working with your work laptop, maybe you're using Windows. There's Linux, there's Android. All these things are operating systems. The most popular ones for like backend servers is Linux.
Okay.
So the third thing will then be the hardware. So as I said, there's a data center that is physically running your code. So if, for example, tomorrow your company gets richer and they just change, just like you changing your laptop, and they just like buy extra hardware, then the code you've written automatically becomes faster, even if you didn't change the code. Do you see?
Yeah.
So it's almost like a mechanic. Think of it that way. Like if you're a mechanic, you need to know how to drive a car, but you need to understand what your car is driving on. Like you can't just write code alone as a backend. You need to know where's my code running. So if tomorrow they come to tell you, we made more money than we planned, we want our code to move fast, what should we buy? You should be able to say as a backend person that, why our code is this slow at this moment is maybe we're using in iPhone 10, we're using iPhone 13 of the data center's hardware. So we want to buy the iPhone 17 version of it that will make it faster. So you can write the same code today and in 2 years' time it's faster because you change the hardware under it. So it's basically in three layers. There's the programming language you need to learn. There's the operating system you need to understand. And there's the actual hardware where your code is running. So a fully versatile backend engineer should touch all of these three things, even if you don't do them to full capacity.
Okay. So it sounds like there is an insane breadth of what is possible in backend engineering.
Yes.
When people explain, so usually when you ask people, what do I do? What do you do? Full stack, front, backend. I think when they start explaining what they do to you, you start understanding. Because when people think of backend, there is probably a simplified scenario happening in their mind
Yep.
as to, or you probably just write code to make things work.
Yep.
But the breadth of what you make work is not visible. I don't think I understand.
Yes.
From what you're saying, it feels like it's endless.
Yes.
So you said language, OS, hardware.
Yes.
Now, first of all, are there backend engineers that don't, probably a cheap question, but don't write language, but deal more in the sense of developing OS or hardware?
That's a very good question. So there are people that are just hardware engineers.
Yeah.
Basically, they are data center managers, which is why, like, when you start out coding, sometimes you feel like what you're doing is very limited, because when you start a new job, they put you in a very small space. So we want user A to debit user B.
Yeah.
So in your own world, that's the only thing that exists. You don't think that there's a hardware. You don't think there's data centers. You don't even think there's an OS. You're basically just writing your code.
Yeah.
So the more you delve deep, you realize, oh, where's my code even running? Oh, like, where's the data center hosted? Oh, there's AWS. Like, how do I do this? So people start out, almost everybody starts out coding, but some people don't write code anymore. So there are people that all they do is hardware consultation. So you have a big company, you want to buy new hardware. You're like, oh, this is where I'm going. So for example, there's AI. AI's hardware is different from the hardware you want to use to watch Netflix. Yeah. Netflix hardware is different from the hardware you want to use for fintech. So there are people that if you use the wrong hardware for what you're doing, then your thing automatically becomes slow. Not because of the code the person is writing. So, but you need to know what code is for you to even know that this is possible. So you start out coding, you move out, and some people become operating system engineers alone. They don't write any business. They call them platform engineers. So you don't write code that people use, customers make money from. Because what the operating system is your customer is a software engineer, because his code is running on the operating system, if that makes sense. So engineers are now your customers.
Ooh.
Do you see? So the operating system engineers are a different type of, but they are also, which is why, like, when you get that far, you realize there's nothing like backend anymore. Like, it's many things. So there's the hardware people, they don't even call themselves backend because they're not writing code anymore. They're doing hardware. I mean, you test the hardware. So let's say you buy a new phone. Yeah. You want to test which one is faster. You write some tests to do it. So yes, there are people that eventually you're very passionate about doing hardware, doing the hardware alone. You can end up, but the company has to be big enough to, because
for you to make that
yes, because very small companies outsource all of these things to like AWS, so you pay for your own cloud, so you don't really do that. But you can think that whoever is in AWS, that's what they are doing. So they have hardware people, they have operating systems people, and yes, they have normal backend people, which are people writing the code for the business logic of what the company is making. But there are many other people that don't do any of that, but they are still part of the company. Exactly, they are still backend.
Is that platform engineering stuff you just explained is actually interesting. So one of the guests on this series, so what he does is, I think AI platforms or data sharing system platforms are probably sure I'm oversimplifying or using the wrong words. Yeah. But essentially, when two companies come together, they say they want to share data. Yeah. His own is to sort of define the architecture of the environment, digital environment where they will share that data. So I'm guessing that's probably something like
something like that. And it also depends on your kind of person. So if you get joy from customers, like you like building products, then hardware operating system might not really be your thing. So for example, some people are like, oh, I want a customer to say, this feature did not exist before, but now I can watch Netflix on my watch, for example. Some engineers enjoy that type of thing. They prefer, oh, how much is this product I built making? I built it last year. How much has it made this year? You say you made $1 million, 100 people are using it. That's interesting to them. Some people, what they find joy in is more the lower level things. I don't want to hear from any customer. I just want like to build stuff that other engineers will use. I get more joy from other engineers using my thing. You go lower. So you do like more operating system stuff, hardware stuff. So it's not just like some people feel there's a stereotype like, oh, the hardware people are smarter than the operators because maybe you're scared, you don't want to do hardware. But that's not really the case. Even if when you start out your career, you most likely won't do hardware first. But it doesn't mean people that are writing code till now are not smart or they don't know the hardware. It's just where you find fulfillment in. So you have to also find that balance.
Yeah, because I think it's also interesting because I mean, there's also a thing of what opportunities exist where you are. I don't know how many companies, for example, in Nigeria or let's say maybe in Ghana, this is subjective opinion, that do hardware or OS. For example, I'm guessing, given from the examples you've explained, operating systems, or which one of them is, you have AWS and you have the likes of AWS. Yes. I don't think that Amazon has offices that do that in Nigeria or in some places in African countries. So automatically, your experience, and these things feel very physical, so in person, it's probably limited to what you can do virtually. Yes. So that means automatically that limits the amount of where you can expand to your back-end experience if you want to get into this.
Exactly. And to flesh that out, before Amazon or AWS is one of the biggest things that ever happened to backend engineering. So before AWS was created, if you want to start a business today, you would buy your own hardware. So basically, you need a hardware person. You would buy your own, set up the OS on the hardware. Then you will now employ the engineers to write the code for that. So most of the businesses that were very big were not African based or like Nigerian because we hadn't gotten there yet. So what AWS did is, don't worry about hardware again. I'm buying the hardware. I'm handling like the operational cost. I'm doing all the operating systems. So all you need to do is write code forever. So basically, just pay us the money. What I'm explaining now is, when you start out coding, you would never most likely ever do anything with the hardware. You know, just click, oh, this is the hardware I want to click on. AWS handles that. But I'm saying you're going to scale to a point where you then want to work for AWS. So you get to a point where that thing that you think is just a black box, human beings are actually doing that thing. So you don't want to box yourself in a way where you can't actually grow beyond. But so you can live all your life. You've never touched the hardware before. It's possible. So but what I'm saying is, many businesses don't even need that because they're already people's business to take care of that. AWS's business is basically will handle the hardware and the operating system for you. You never need to do, all you need to do is click and say, I want this one. If you have more money, you click and say, oh no, I want this one. So basically they just package it for you, almost like what Apple does. They will tell you this is the new, they call it EC2, whatever. They have their names for the instances, the same way iPhone has models. So if you click the latest one, you get more CPU, you get more RAM, you get more memory. But just know at the back of your mind that you should be curious enough to say, where's my code running on operating system? Where's my operating system? Many of the time, you just even need it to pass an interview. Like, if I'm interviewing somebody, none of you have ever worked on hardware stuff, but somebody explains to me that, oh, my code has hardware, I'm just going to choose that person because I know that any day my business grows, he can scale or she can scale versus this person that doesn't really know that thing exists. So sometimes you just actually just need the head knowledge and it will help you well enough, even if you never touch it.
All right. Let's go into one of them a little bit. The one that I probably know that is more popular with the audience that we series of conversations tailored to language.
Yes.
Not JavaScript.
Yes.
Can you explain?
Okay. So I will preface with saying languages are almost the least important thing to care about, even if they are so important.
Okay.
But if you box yourself in like, oh, this is the language, it doesn't really mean anything. It's like saying I speak Igbo. Can you speak is what matters. So how can you communicate? You can go to a different company and it's Yoruba. So how well can you adapt? And if you do languages in real life, you know there are some things that carry over. So there are nouns in every language. Or they have everything. So I will say focus more on learning that. For example, I started out writing no JavaScript in 2018. I've not written it for 5 years now because my company is using something else. But if I go back to use it tomorrow, I will figure it out because I know that there are core things that exist in all the languages that you need to know. So languages are very nice. People argue over it. It's like how people are passionate about French versus Spanish. There are just some things about a language that makes it look nice. So there's also that. I won't say I like some languages more than others. I just like it. But I will never advise anybody that, lock yourself into the one because all those things change. But basically, no JavaScript is popular most because JavaScript was the language they use on the front end. Yeah. So initially, the front end team will write JavaScript, and then on the back end, they write something else like C#. And then they got to a time where they're like, can we make JavaScript just front end and back end? So if you learn it once, you can write it anywhere. So people now are full stack. You can write front end, you can write back end. Okay. So there was nothing about the language in itself that made it so popular. I mean, it's simple and the other things about it, but I think the main thing was the front end engineer can look at JavaScript and the backend engineer can look at JavaScript. So it's very ubiquitous. It's very versatile. Yeah. So that's what made it very popular. If a company interviews you on a language, it's even almost a red flag. Like very serious companies don't do language interviews. So
what do they do?
They do more infrastructure interviews. Like, what is the OS about? Or what characteristic of this language would you use to solve this issue? So I'll give you an example. Like the same way languages have nouns, all languages in coding have something called maybe functions, for example. Okay. So any language you ever write. So if I interview people, they can use a language I've never seen. So if you limit people to a language, you lose very good engineers. Yeah. There's some engineers that have never written a language you want to hire them in. So when they're doing the interview, you can tell them, use the language you want. But because you've learned how to code long enough, you know that thing doesn't look, if you see something that is wrong, you just know. So languages have things that, all of them have variables, all of them have functions, all of them have some type of asynchronous processing they do. So basically, there are things that carry over. So today, someone's creating, languages are one of the most addictive things in like coding. People create languages every day. So really? Yes, like some people's final year projects in school is create a new language. So there are many books on people creating new languages. Companies have internal languages. So my company has a language we only write in-house.
I have never heard that.
Yes.
I have. And I mean, it's like having your own internal tech platform. Go on.
Exactly. So the way many languages are formed eventually is when the company internally feels that, this language is robust enough, they open it, source it. So many languages There's a language called Go. It's Google's language. They use it internally for many years. And they're like, oh, it's good enough. Let the world have it. So even operating systems, many of all these things, companies already have them. They own them inside for their particular use case. Some people don't just like the semantics of the language. Like maybe you want to type hello world, it takes too long. I just want to type HW for some people. So you can create a language to do anything you want. You can be like, oh, I want to optimize for text. Like I just want to say 2 plus. So even like a calculator is a type of programming language. It's just a mathy kind of language. So languages will exist every time. What people focus on is how popular is it, because if it's very popular, it means it has support. So many people have fixed all the bugs you would have found. Like I won't go and use a language a student just created yesterday because it means it has a lot of bugs in it. So the more tested and trusted a language is, the better it is. But I won't really advise anybody to focus on any language. I mean, pick a language and learn it. Don't jump around learning multiple languages, but also learn the fundamentals of a language. What are variables? What are functions? Like what does async processing mean? All of that. Because all those things exist in all the languages. So if you have to pick up maybe 6, 7 languages, I start coding. So imagine I was saying I only do no JavaScript jobs. You're limiting yourself. So I won't advise you to just focus on that, if that makes sense.
Okay. So I am thinking very narrow in this conversation, but it feels like you want to blow it up. So let's blow it up.
Okay.
Given that you are saying you don't really need to be so obsessed with learning a language. If I am, and I think you hit on it, but I think let's expand on it more. It's probably not a technical conversation, a very technical topic. If I am starting today in backend engineering, you are saying that there's a question you said when somebody comes for an interview.
Yes.
You are more concerned about what future of this language will be able to solve this problem.
Yes.
Explain what that is.
Okay. So the way interviews work mostly for software engineers is in 2 ways. So there's one that is called system design, which means you're not going to write any code at all.
Okay.
You're going to draw diagrams explaining to me how a particular system would work. So popular questions are like design Twitter, design Netflix. So what I said now, if somebody designs Netflix and he or she doesn't mention that for Netflix to work properly, you need a CDN, which is what I said. Like you need to put these movies in. The person has failed that. There's no other thing. If you like write the best language in the world, you just don't know how it works because it means you can't scale a system. Okay. So basically, system design is design a system for me. You're not writing any code. So to pass that, which very big companies do, you need to know about most of the things I've spoken about today. What operating system, what are. So that's just fundamental. Then secondly, it will then be a coding question. So like there will be like a popular algorithm they want you to like help them solve. So they can tell you a trick question like if let's say 10 customers are trying to pay here, what algorithm would you use to like maybe manage their payments? So then you have to write actual code. Most of the time they can tell you to use any language you want.
Sorry. Algorithm code.
Yes.
I don't understand. Are they the same? Are you explaining the same thing?
Yes.
So you can use, is it that algorithm is another word for code in this context?
So an algorithm is a defined set of steps to follow. So code, like the code is the most bottom. An algorithm can exist without code. So mathematicians have been writing algorithms before. So there are popular algorithms like, what can I use now? So there's something called like Paschal or rafts, but those ones are very complex. But an algorithm, for example, can be like, if you want to leave this house, you have to open the door. That's an algorithm.
So
yes, it's
like
just steps
recipe.
to take. Thank you.
Okay.
Exactly that. Code is just writing that cooking recipe somewhere. So you can explain an algorithm without. So you won't just start writing code. They're like, what algorithm do you want to use to solve? There's a way you can leave this house in 100 steps. There's a way you can leave this house in 5 steps.
Yeah.
So you won't come and say, I want to leave the house. I go and hit my head on the window and then I start going to, you failed it. Even if you write code. So writing code is addictive. Like when we start coding, you're like, oh, how many hours do I do today? But you need to force yourself to do every other thing but right. When you're writing your code, you should have figured out the algorithm. You should have figured out how you want. So the biggest red flag for failing that test is to start writing code immediately. So anybody that actually just starts typing out the code is not most likely going to pass because you didn't do, there's something they call requirements clarification. So you're like, oh, how fast should I? So you're going to explain your thinking to the person. So I can tell you, for example, to go out of a particular room, you can do it in 3 steps. But that would take me 5 hours to do.
Yeah.
This is a short interview. I want to do it in 20 steps. And they're like, okay. So they already see, okay, this person knows that there's a 3-step solution. But someone doesn't, okay, let's start typing juicy. So that's what I mean. There's an algorithm. It's just cooking recipe, as you said, is a set of steps you want to follow. So you explain that to the person. And then they can tell you, okay, start writing the code for it. So the person is experienced enough. Sometimes you don't need to run the code. I've written interviews where my code didn't run. but it never mattered because they know you've said enough. When you start doing the job, you figure out the code, you Google it, you use AI, which is what AI is doing for you now. You might not even need to write code again. Some people use like audio and they just talk and write the code. So what matters is like, do I know the problem I want to solve? So it's addictive because coding is what's called. Some people say I'm a coder. Even if that doesn't really, it just means you're a typer. So what you want to do is, what you want to do is understand the algorithm you want to actually use and then type the code for it.
And type the code for it. Okay. I never knew that people could just create languages.
Yes.
So if I wanted to create a language tomorrow, I don't even know if this question is relevant, but just humor me. Like, what are languages created around a particular problem people are trying to solve?
That's a very good question. So yes. So think of it like, even in movies, like in Game of Thrones, they created a language for the movie. In like Dune, they created languages for the movie.
Okay.
So in academia, they love creating languages. Like a new professor can be like, I want to create, because they are very, very like picky about the things they want. Some people don't just like the way language looks, even if it solves an issue. So there are different types of languages for different things. Some people have specific issues where, for example, Excel is a kind of programming language. Yes, because you can type in some functions in your box that will make it. So they designed it for that particular type of industry because they don't want those people like doing. So yes, people create languages every day for just one use case that they want to use. But there are things they call general purpose languages. So these languages you can solve most problems.
Okay.
So you can use it. But tomorrow you can wake up, define a syntax for your language the same way you do in real life. So if you want to type JavaScript today, yeah.
Syntax.
Yes.
What is that?
Good. So if you type JavaScript today, if you type the wrong thing, then your code won't compile. So for example, you should be able to go and type, there's something called valid JavaScript. Like you can look at a JavaScript file and tell this is JavaScript or this is not JavaScript. This is like if you type in your code editor, my name is Faith, it's not going to compile to anything because that's not the valid syntax. You have to say let Faith equal to something for it to be valid syntax.
So is syntax like the way a sentence is structured?
Yes. So it's the way the language is defined. So you can define your language. You can say, I want my language to contain these particular words. These words are invalid. You can't use it. A language can say, I want my language to always end with a semicolon. So if you're writing JavaScript, after every line, you must put a semicolon. That's syntax. It just means the person that created it wanted it that way.
It's like the laws of the language.
Exactly. Then. Exactly.
Okay.
So there are things that make that language valid. So you can look at it on a piece of paper. People can write a language and read and say, oh, this is not valid JavaScript. The same way you read something and say, this is not valid English, this is not valid French. You can read JavaScript and say, this is not valid JavaScript because it's not within the syntax of the language. Some people want better syntax, they create their own language. Some people want faster like programming languages, they create their own language. Some people want it more for like the backgrounds they come from. So some people come from financial backgrounds. They don't like the way whatever the coding people are doing looks. They want something that fits more to their pattern. They create that. SQL is a type of language, but it's more English driven. So they're like select all from this table, group it by 5. Is a language, but basically you can't use JavaScript. You could have used in a type of way JavaScript for that, but they want a different syntax that matches more with that thing. So languages are created every day. With AI now, there's something called CUDA, is a JavaScript for AI stuff. Okay. Some people are even saying they want AI agents to write their own languages, whatever they feel, because basically they want to get AI to a point where English is the programming language in quotes, which is what prompting is. Oh, just do this and then it does it, something like that. So people create thousands of languages. Many of them never become popular, but it's also a very good algorithm hobby project to try. Most people have tried it. Like as part of your learning, you try to create it. It doesn't blow. You move. I haven't. Funny enough, I haven't. I'm just really not a language person. I'm more like, what can I build? I don't really care about languages, which I'm sure by now.
You need the code to build the product.
Yes, I'm just not passionate. Like, I mean, I've read how to. Maybe I have tried or I have started. I haven't finished. And some of my friends have finished created languages. I've tried. There was a language called Yolang, which was like Yoruba JavaScript or something. Yeah.
Are you serious?
Yeah, it was popular in like 2019. So yes, there are also people that don't speak English. Most of the program languages are in English. So people can create ones for their own languages.
That's true. I think somebody said that most of the prominent programming languages are all in English.
Yes, because I mean, a lot of the computer science history in the world started in America. Yeah, so many people, I have many colleagues, they don't speak, they just have to learn English for coding sake. Yeah. So many people can have languages for their own. Yeah, so there was one for Yoruba. Yes, exactly.
Or you want to use very
and then So it's a very big space. Like companies hire people specifically to write languages just for their internal case. Like, okay, I want to do this. I don't like anything I'm saying out. Can we create something for this use case? So it's very possible.
Yes.
Yeah.
I had somebody to go. Okay. So operating systems, right? You spoke about Linux and AWS.
No, so AWS is the business around it, but there's Windows, which is what many people use. Windows is an operating system.
Operating system is there?
So there are many. There's Linux. There is Mac OS, which is Apple. Okay. That's an operating system. Or it's called Darwin.
Do you know that? I feel so stupid asking that question because I remember computer science.
You were doing all those.
They say
they're like the operating systems and stuff.
But okay, so I was asking that question because of how you've blown it up to say if you are in backend, you should not just be thinking of code, but you're thinking more broadly.
Yes.
And so exposing yourself to all these things, what are sort of the differences that some of the OS you are quite familiar with? What do they present?
Good. That's a very good question. So firstly, the major thing here is in software engineering, they are very big on open source. Open source means like everybody can see. Yeah. So like if you see when what was a good example? So Linux is open source.
Okay.
Windows isn't open source, it's closed source. So only the Microsoft business knows what it looks like. Apple, macOS is closed source. So the reason why Linux is the most popular language for servers or like backend is because it was open source.
Okay.
I mean, it's a very good language also, but part of what made it go so popular. Because one thing with open source, it means anybody can contribute to it. There are very smart people all over the world. Every day they are telling you, oh, let's fix this way, let's do this way. So Linux is like the center, the poster child for operating systems because it's open. You can download the code today, read it by yourself. So, but if you're an enterprise business, like many places you'd have worked at, many people use Windows there. Some people also use Windows for the servers they want to host. So the market is fairly between those three people. Like very client devices, the iPhones everywhere, that's their own. Google devices have Android, which is what people use. But backend servers mostly have Linux on it. So if you learn just what Linux does alone, you're mostly good 90% of the time. So only very like niche businesses, older businesses, banks, many of them were like there before Linux even came out. So they have some like Cobalt or Windows. But if you learn Linux, most of the time, everywhere I've worked, for example, we all use Linux. So it just offers a wide range of many of the capabilities that other operating systems like also do. Okay, so a good one would be like extensibility, for example. So, it's complex, but if you want to add new stuff to an operating system. So basically the way the operating system is, let's just imagine somebody builds something for you and gives you. Think of it like an extension. With Linux, you could like plug your own. So you bring a USB cord and plug and be like, I want to charge my phone, I want to charge. So it gives you a platform for you to add more things in it. So with Windows, you can't do that because it's closed source. So Windows, Microsoft will build it and ship it and give you. So whatever you have is what you can use. But with Linux, is more extendable that way. You could build your own modules on it. So there are many things the operating system doesn't do, but many people have built on top of Linux. There are even like flavors of Linux. There are different distributions of Linux. Yes. So people like choose, the same way there are flavors of a language as well. There are dialects of a language. There are different flavors for Linux and different distributions of Linux that people then use to be like, oh, I like Linux, but I like this Linux. This particular Linux does what I like more than this other Linux, even if they're all Linux. So open source just makes people more creative. They can do more things on it. But operating systems generally are quite niche and complex. So most times you would never write an operating system yourself. But knowing what it does would give you that extra edge, like for interviews or for like debugging stuff, for example.
So people need to go and figure out what the different OS offers. And which one. But if you are able to figure out Linux 90% of the time, you're good.
Yes, for sure.
Okay, we will not try and figure out Linux in this call because that thing you're explaining, it will break my head.
It's a break my head too.
Okay, so, but I think we've touched on hardware a bit, which is like the physical systems, essentially, where all your data is stored and your information. It feels like hardware is not just a back-end thing. It's a digital product thing. So ultimately, no matter how digital anything is, there is a physical place it needs to be stored. And now with the advent of AI, we're seeing the hunger for data farms rising up everywhere because I mean, somebody needs to ChatGPT.
Exactly.
Claude something that it needs to be housed somewhere. Okay, so it feels I'm quite interested in it's probably just a funny thought, in the engineering that knows hardware across the different kinds of engineering. So front end, would you say that it's the same hardware? Because ultimately these are all digital products like website, like applications. Do they use the same hardware then?
Yes, but the difference is, as I said, the hardware your code is running on can determine whether your code is faster or slower. So imagine tomorrow you get a call saying, "Oh, Pascal, you finished building this product for us, but the customer is waiting 3 hours for it to load, and yesterday was 5 seconds." So as a software engineer or as a backend engineer, you can spend 3 days looking at it saying, "What did I change about my code? I didn't change anything."
Yeah.
Because you've not really thought about it as far to say as where is my code running, what hardware is it running on, do you see? But let's say you wake up the next day and you figure out that, oh, somebody deployed your code to a very small AWS instance that didn't have the right amount of memory, which is why it's slow. So knowing that, oh, that even exists, or there's that layer, would help you like decide what to do, or like what should I like choose there. So as you said, front end, any end, they all run on hardware. But sometimes a more natural progression would be like, after doing backend for a while, you want to like try something else. Many people do hardware stuff. Some people also just do hardware stuff directly. And there are many companies that like cover this. So like Intel, for example, is a hardware company. AMD, ARM, many of these people, they just make like the actual hardware. So they have like electrical engineers, for example, that's part of their business. IBM, for example, that's part of their business. So those are the ones actually like welding and soldering the parts together. And then whatever is going on this hardware are like chips that's from people like TSMC and ASML, all of those companies, NVIDIA, all of them.
Dell.
Yes. So, but Dell's one is mostly customer face. So they are the ones that like face like, and laptops. Then they are the ones, that for like data centers. So yes, even with hardware, you just need to know some of the different possibilities of them. And like what would make my code like what about the hardware makes my code faster? And there are 3 major things. So the first one is CPU, which I'm sure we've all heard about.
Central processing.
So if you're I mean, you can call it cores as well, but you can say if I have 3 CPUs, which maybe a small laptop would have, versus a data center's server that will have like 96 CPUs. My code might. It's also possible it doesn't run faster there because that's not what the problem. Yes, because that's not what it's bound by. But let's leave that. But basically, you can say it will run faster because someone can show you like the 2 specs of 2 servers and be like, why do you think, like, what are the 3 things you look out for here? So the first thing is CPU. The second thing is memory, which is also like RAM. So you can say, oh, my laptop is 5 gig RAM, it's 10 gig RAM, it's 20 gig RAM. So the more RAM might mean like more space. Yes. And then the last thing is like the disk. So they're like, oh, what's your storage size? You can be like 500 gig or 1 terabyte, blah, 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 blah.
You know when we used to have all those wonky laptops?
Exactly.
That you need to go and check I can't remember, but you'll be able to see the local disk,
yes,
the RAM.
Yes.
And so it helps you figure out why my laptop is
slow. Yes. And you realize that, oh, Chrome has taken 98, you kill it. And then you realize that you've gotten that space back. So yeah, basically those are like the 3 major things that if they ask you, even if you don't know anything, and they are like doing an interview, like, okay, if I want to buy a new hardware today, even if you're not a hardware engineer, what are the things I should look out for? And I think mentioning those things alone creates a type of edge. There are some very good books. There's one just beautiful book. It's called Systems Performance, and Brendan Gerg is a writer. But yeah, that just covers like everything: hardware, CPU, memory, disk. So yeah, that would just help you. You might never do it. I've never had to buy a CPU, but these questions come up because many people know many things and they're trying to say, oh, who just has that edge over like the other person? So it's just head knowledge that sometimes is useful, but sometimes it's not. So a good example would be like something like Netflix. This will be a very simplified example, but you're watching the movie. So let's say you're watching a movie. The movie is using a lot of space. Just think of it this way. So if they ask you, if I add more CPUs to this, so let's say it's using a lot of space and it becomes slow. So for that type of business, what they need is more RAM versus more CPU. So you can't just throw CPU at the problem and solve it. So they can ask you things like, is this program CPU bound or RAM bound or IO bound? So those are the type of questions you hear. So you have to then think of it like, oh, some businesses need more RAM than CPU. Some businesses need more CPU. If you're doing like a financial application, you're doing a lot of math, you need way more CPU than RAM. If you're doing like a more streaming kind of business, you need more RAM than CPU. So, which is why I said 96 CPUs doesn't mean your code will run faster, because it depends on what the code is doing. So, yes, those type of questions come up as well, where they can ask you, like, okay, like what kind of parts of the hardware do you want to scale for this type of thing you're writing to run properly?
All right, so I think we can definitely go in hundreds of different directions. In my head, I want to think, okay, so how do you know? I mean, you've answered one of those questions as to how do you know when something is RAM or CPU, but that's a different rabbit hole.
Yeah.
I want two different questions, but I think maybe they are similar, but I'm not sure.
Okay.
So going back to the interview question, when you said systems design, I am guessing that is related to when you are presented a problem as an engineer to solve, and then you have to think the process through. Now, what does that look like? That's one question. Another question that I think I have is in the digital product pipeline, what is your role? What is your job? And sort of what makes you do that better? So in clear terms, so for example, speaking with the product, I understand, at least from my limited knowledge, you start with the product side. Then all through you are working with your engineers, but the product needs to do their bit. The back end needs to do their bit. The front end needs to do their bit. You need to join those two together. And then meanwhile, UI UX is inside there somewhere before you release the product. I mean, all these ones, they are iterations. I mean, with design thinking, is it design? The one where you are releasing it in bits and bobs. So you don't design the entire thing before you release it. So walk me through exactly. I think, is there a question?
That makes sense.
Okay. So walk me through the first question around systems design. What is that? Okay.
So as I said, most times your interviews want to check for two things. Sometimes, to be fair, it might not be really necessary if you're in a small company, because most of the system design questions are, if 3 million people visit these sites, what will you do? And I'm like, 3 million people are not visiting your sites. It's 10 people. So let's do that. So, but for very big companies, those are real questions. And sometimes events happen. So there are some companies I worked for, like there are certain times in the year, Black Friday, where those 3 million people actually come. They might not come January but they will come around that period. Or there are events like Big Brother and you're hosting or you're sponsoring a very big event. People come to your site that day, takes the site down. So even if those questions are theoretical many times, it's just trying to get the hang of the day problem happens or we end up blowing up more than normal, what will happen? So those type of questions, you're not writing any code at all. It's just you with a pen and a paper or a mouse drawing diagram showing my server is here. So a typical question can be like, design Twitter. Like, how do you think Twitter would work, even if you've never worked for Twitter before? And then you start to explain what your requirements for this particular system are. So you can ask clarifying questions like, okay, I'm going to design Twitter, assuming there are 100 million customers or users per day. And your interviewer is like, okay, yes, good assumption. These 100 million customers are tweeting 20 times. So basically just put some round, it must not be a real thing. You just give a rough estimate of this is what I'm designing for, because depending on what your requirements are, it determines like what your design would be. And then you like flesh out the servers you need. So, okay, because of this, I'm going to use this kind of server. And because of this, I'm going to use a particular kind of database. So maybe an SQL database, there's a NoSQL database, there's a graph database, there's a vector, depending kinds of databases. But depending on, so let's say for Twitter, you say you want to use an SQL database and you design what like your API will be and the protocols you want to use for communication. So there are many things and it's open-ended, just like what we're doing. The more you talk about it, then the more questions come up. So sometimes you even think you failed because you've done the basic part so well. They just want to see, okay,
foundational.
Okay, keep talking, like, but you've actually just passed the interview, but maybe pass it too fast, and they're like, okay, let's probe. So why do you want to use it? And you're like, I don't know that one, but you've already passed at that point. So many times they just want to, because it's an interesting discussion, just for that preview. So it's more open-ended. It's way more interesting, I would say, than even the coding ones. Coding ones, if you don't know the algorithm, it's over. you can't. It's almost more memorizing. So before the interviews with the coding ones, you have to read. People literally have businesses that teach you what will Meta ask you in your coding, what will Google ask you in your coding. So people pay £30 maybe for a month. So just lock in and prepare for those coding interviews, because if you've not seen it before, you can get it, but it's just way harder because you have to then think of the solution on the spot. But system design is almost more like your day-to-day. You can wake up tomorrow. Many of these big companies like release blog posts every week because they're very proud of what they've done. So Netflix will write a blog post saying, how do we scale to the whole world? And you read it. So it's just basically what you read every day they ask you. So it's way more conversational. I also talk about it that way. So I would say system design is just a conversation explaining how you would build stuff. And mostly like reading blogs of companies that you're interested in will help you prepare for the interview. So, but the second question is mostly working with a good like product and engineering manager that handles most of the roadmap. So I think the way it would start would be like, this is a new quarter we've been ushered into. What are the things we want to achieve as a team in this quarter? So we come up with a roadmap. The PM has done some kind of research, user research.
Product manager.
Yes. And come up with the things that are most integral to the team or more priority based on whatever metric they use. So maybe which product makes the most money, which product has the most users, whatever they want to use.
Yeah.
So they can say ABC are the top 3 things we want to work on this quarter. And then that now hands over to the engineering manager, which is like, oh, I think engineer B is best suited for this. So you get assigned one of the projects on that for what's required for the quarter. Now, you as the lead engineer for that project then writes out what is called a specification. So think of it like, how would this project work? You've not written any code yet, just because you want to set timelines. Let's say you're in March, April, the customer wants it in 1 month. There's a way you write documents. The whole world can see it won't be ready in 1 month. I don't need to tell you. Look at the things that, so you won't just say, oh, I can't do it in 1 month. You need to explain why you can't do it. So basically write a document saying, if we want to do this, we need to set up a new table. We need to write a new API for this. So when you're done all of that, then your engineering manager is like, okay, can we write this into tickets, into like whatever ticket management tool you're using, maybe Jira, maybe anything. Okay.
What is ticket management?
So there's like Jira or like Confluence, or basically...
Is it like your project management tool essentially?
Yes. So it's shared between the project management team and the engineering team, basically to keep tabs on each other.
So what's the ticket?
So a ticket is just you describing something, saying, is a task, basically. So if you say, this new project requires 5 tasks, you're going to create 5 tickets for it. And then when you're done with that, your engineering manager will be like, with these 5 tickets, how long do you think every ticket will take? So when you do that, then you sum up the total of the 5 tickets and you come up with the time. So basically, you're like, from these 5 tickets, this will take 3 months. And then your engineering manager can then decide, if you want it done in 1 month, then I need 3 engineers on it. So that then determines how many people do I put on this project. So it's a very nice way to know. For example, I've worked for some teams where we've decided that 6 weeks is a good project for 1 engineer. So if you see a 4 weeks project, then you don't need 2 people on it. It will just become, sometimes putting more people makes it even slower because you have to synchronize with them and do so. When it becomes more than 6 weeks, okay, we need 2 people on it. So basically, the engineering manager tells you, okay, the specification you've written looks good, you've created the tickets for it, this will take this amount of time. So he communicates that to the product, which talks to the customer. And then from there, you just like start writing the code for it. So yeah.
So from your description, it's very evident you work in a large company.
Yes.
Or you have experience working in large companies. Because usually when you take this conversation with people, they usually take it to the sense of building a new product.
Yeah.
So how a PM does it, and things like, but you are thinking of there's a different way you paint the picture that just gives that large scale experience, which is I think helpful for our next question, because we can definitely go on geeking or I just saw that it's actually almost what
exactly.
But what's the difference actually between working in a small company where you are in constant firefighting mode and a really large one where it's just really large? I can give adjectives. I don't want to decide where you go to.
That's a very good question. So I think the first major thing for me was control. And it's such a big thing because when I was working in a small company, I knew everything that was happening. So this code base, I know it. Like, you can't tell me, no, this is where this is. This is where I slept in the night, I woke up. This is how the code is. But in a very large company, you just are not in charge of anything. So like, I feel bad sometimes, like, what was all this? Like, because you wake up, some people send me text of what my company has launched. I didn't know about it because there are so many teams, so many things are happening. So I think the first major thing is, don't even think for a second you can understand everything that's happening. You won't work. Because normally I like reading what other people are doing, find out let me see how it affects. But the first thing is just the scale. The sheer amount of scale compared to a small company is just very different. So you can't really like control most of the things people are doing, which means somebody else's stuff can affect your own. And that's why there are way more processes in place in like larger companies. The second thing is just the global nature of very big companies. So, for example, there are some things you just never think about working in a startup, like GDPR stuff, and like, oh, this customer wants their data only here, and you don't want it in. So, which is so interesting. Like
GDPR, just what's that? Just for awareness.
Okay. What's the full meaning now? Do I even remember?
There's guidelines.
So regulations, basically. All you're saying is there are regulations, there are data laws as to what you should do with customers' data, which is way more important, like in the West. And you work with like governments as well, with big companies, which I mean, like you're working with governments and they're telling you, okay, this is the level of security we want this to have. Like this can't happen here. Yeah, so basically the global scale at which you're working on is way bigger. Like you're following actual events happening in the world because you might not be able to release things that day. So they're like, oh, this is happening, this country is announcing this, put off whatever you're doing. Don't write any, before you spoil what we have going on there. Or like we have a big demo to this government today. Please, nobody should write. So there are some days where you don't do anything. They're like, go and read the book. Like, leave the code alone for take public holiday. Don't spoil what we have going. Don't touch anything, please. So yes, it just makes like even rolling out things very, very difficult. So in a small company, you can be on a call with the customer. The customer is like, oh, this site is not working. You're like, check again. And they just refresh it. And there are some changes we make. It takes 2 months for it to roll out.
Are you serious?
Yes, because like if you're in the UK, to roll out to maybe like the data center in the UK alone, it can be there for 2 weeks. So you have to test that. Because imagine rolling it out to the whole world at one, you're going to break your, like you get sued, like exactly. So you roll it out to a small data center near you, you test it for a while, you're like, okay, it works here, you roll it out to Europe. Okay, it works in Europe, roll it out. So like is in a small company, you could ship like 20 features in a year. In a big company, you ship one. Like, if you're so great, you ship two. Like, that's if I do one thing, I write a blog. It's such a big deal. Like, because there are so many times you finish doing it and you might never ship it. So they're like, after 9 months, we don't really think this is what the customer wants, and you drop it.
Wow.
So yeah, the scale at which small companies the other way around. You ship so much, they tell you unship it. You have to bring it back because you've done so. Yeah, so
Wow.
it's almost like some people can't do it. So we've had people at the team where they're like, no, from where I'm coming from, you people are killing me here. I can't do like this is too slow. And we are even fast. Like there are companies that are I know people that have been 3 years, they are still on the same. So you find joy in the process. You don't really care about like results. I mean, you care, but it takes a while because what you don't want is, we lost money because of you. We lost to work.
And that money will not be 2,000 naira.
Exactly. So yeah. But yeah, the reach is more like, I mean, you won't be able to come out and publicly say sometimes, but you just see some things people are using. You're like, I am the one that did that thing, and it's like way more popular than. So it's way cooler, and like the customers that are using it are like big names, so you don't want to like actually do anything to like break whatever they're doing. So I think those are the major things. I mean, there are many other like smaller things, but yeah.
So I think a simple answer to, there's a question I have in my head. I'm just thinking of time as well, because I also want us to get to know the non-technical bit.
Yeah.
Around there's a term you were using just now when you were explaining the process of how projects come up, the engineer manager or something.
Yeah,
like
the engineer
that.
manager. Yeah.
Now, most people have the sense of growth in engineering.
Yeah.
And from my conversations, I'm beginning to understand that it's not linear. The thing is is very up and down.
Yeah.
You are a senior engineer.
Yes.
Do you have people that report to you?
Sort of, yes.
Okay. So some people don't have people that report. What's the system like? Because, for example, with a front-end engineer, somebody was explaining to me that there's a front-end developer, there's a front-end engineer, there's somebody who thinks of the entire system, and then they now have front-end engineers underneath them who are managing specific parts of the system.
Yeah.
What does growth look like in backend?
Okay. That's a very good question. So, firstly, my team is a very advanced, like, for example, most of the team are senior engineers and above, which is why, like, you might not really have anybody reporting to you because all of you know what you're doing. So there are those type of things. There are younger teams where they are like maybe 2 senior engineers, and then there are like younger people that are like reporting to you for specific things.
Yeah.
So that's possible as well. But the way it works, even if you're on a team with 5 senior engineers, all of you are senior engineers, you're the SME for a particular product. So you're the subject matter expert for a thing. So let's say you build this feature. If anybody else on your team wants to do anything about that feature, they will come and meet you. So there's still some kind of reporting going on. Like they'll be like, oh, before we do this person has to approve whatever we're doing for it to make sense. So that's what reporting looks like in that case. But for some other teams, maybe they are more junior people which directly report to you. You have to like supervise what they're doing. But sometimes you can be in a very like advanced team where you are all senior. You don't really need anybody reporting, but you still have some kind of responsibility. So after that, some people then realize they are also interested in like doing more roadmap kind of stuff, like leading the team where it's going instead of just like writing code. So you want to be that middle ground between talking to, some people just like talking to customers, like, oh, I want to know what's happening, how much you're making. They are more interested in the business side of things. And you don't really want to keep writing code. You can then try to transition to being an engineering manager. But you can remain an individual contributor. Some people go all the way to, we have like a role called distinguished engineer, which like means you've written all the code on it. We don't know what to do with it again. So it's not as if there's no room for growth there. Like different companies have different like cadences for how they want to, which I mean, titling is also a different thing, which can like, you shouldn't get too caught. I don't really get to, I don't really know what, like sometimes people are like, oh, you're now, so it's confusing. I'm like, to me, I've been senior since, so I've been junior. I don't know where I've been. It's not you that will tell me when I'm senior or not. So don't get too caught up on titles. Like, it's funny, we knew someone that refused to change their job because they removed the title from, and the salary was more. Yeah. But they said if that senior is not there, I'm not going. I'm like, I'll be a junior. I don't give me so. Give me the money. It's very company dependent. You can be a CTO in your company and be a junior. Okay, when you move there, you can be a junior. So don't get too hung up on the titles, I would say. But there's also room for progression as an individual contributor. So you realize that okay, managing people is not really my forte. I don't really want to, because there are many other things you have to do. So maybe like, you know how human beings are. Me, I want salary increase. Me, I want to leave. So you have to then start like doing all of that. So if you want to remain an individual contributor, I mean, you still have some human responsibility there because people ask you questions. You still have to be nice, but you don't have to like do as much. You don't really need to care about other people's career growth and all of that. That's not your. You need to like more technically lead the team or like focus on where you're an SME at. So those are like the two major ways it can go for you.
So engineering manager is somebody who is linked to the business aspect of it.
So he is the person the PM would talk to. So imagine like
product.
So the product manager does all the research. He says, this project, customers want it, how long will it take? He's not going to come and ask you, the engineer, how long. So that's a question for your manager. Your manager will come and meet you and be like, oh, do all the ticket size and da. But the product manager doesn't talk. Product manager talks to the engineering manager. All the higher ups, like the VPs, they talk to the engineering manager. So he's the surface for your team, basically. So it just helps reduce the number of people. Imagine your VP has talked to all of you, like it will take forever. So engineering manager listens to everything you're saying. You people have a type of meeting, let's say every week. He knows what the whole team is working on, and then he presents that to like the higher level ups and then tells them. So you have to be very good at writing documents and
speaking English.
Yes, and you should have written code long enough as well. So you can have engineers telling you this thing will take 3 weeks. You're like, no. I've written this thing before. It's 3 days. So yeah, that type of thing. You need to also have like know technically what the engineers are talking about, or you can just choose to remain an individual contributor and keep rising till you're tired. But yeah, that's also possible.
Okay.
Yeah.
All right. So how did you get into backend? Because I don't think that they have backend engineering in
school.
Exactly.
That's a good question. Where do I even start from? So I did engineering in school. I didn't really do computer science. We did some computer science based courses. We did some HTML, we did some C, but I wasn't really keen on it, to be fair. Like we wrote it with pen and paper for context, so it was not that interesting. They're like, let's X equal to 5, we are cramming it. So I didn't really care too much about it, but I just really liked math. I liked science stuff. I feel tomorrow I can leave coding and not really even feel too bad about it, because that was not really my first love. Like what I actually liked was like math and physics and stuff. So it was time for internship. And there are many ways like computer interest could go. So there's networking. What networking means is like, I don't know, like, back home, like you go to a cyber cafe, there are computers, someone sets up the router, there's a switch, and there are people that do math. And that was actually what I was more interested in. So like networking.
Okay.
So I was working for a networking firm, and my friend was working for a actual software engineering firm. So he was coding, but I was doing more networking stuff, which in hindsight was very good. Like it helps me till today. So like my company does love that. And then we come back after it, everybody's talking about this, and I was like, oh, he's coding. I'm like, cool. But then he mentions one coding problem and he has math in it. I'm like, there's math. Let me see. So that was the first thing. I was like, okay, there's actually, because I thought it was design. When we used to do, many people just like, see my green box. I don't like boxes. I don't like UI at all. So I was never interested in it. So when I heard, oh, there's a backend thing, there's math, I said, thank God. So I then we had like a 3-month type of boot camp course, or it should be less than that, maybe 6 weeks or so. Back in school, Python was the language they were teaching. And then me and my friend just stayed back and started going for it. So computer science students were the ones doing, not even engineering. But nobody liked staying back after school. So they didn't even check to see. I wasn't meant to do the course. But they know that nobody willingly does this. Only people that we didn't pay. People are meant to pay, stay back, do the course. But people were so grumpy doing the course. Anybody that does that course paid. So they never asked me if I paid. That was where I sat down. And I was doing it so well, they're calling me Snake because it was a Python course. They're like, Snake, how are you? I didn't pay one. Today I feel bad. I'm like, so I didn't pay. I stayed back. I learned the course. And then there was a site called Free Code Camp. So Free Code Camp is like a free coding learning thing. So I was in that as well, side by side. That was literally it. So the issue is when you join a new company, nobody puts you on the back end because you're a threat. So they don't want you to go and change £1 to please. So I'm on the front end doing color. This is not what I want to do. So I had to do front end by force for a long time, like mobile app. My designs were all green. Nah. I'll move the button green. Say, does this green work? What of purple? No. So I did that for maybe 3 months. Okay, and another thing is like, the company is so small. So the first place I did it, we're just 2 engineers, 1 back end. So you must do front end. Not say you can. We hired you for front end. So I was just doing only front end alone. I ended up going somewhere else. I was doing front end for a while. And then finally the back end person left. I was like, let's go. So I started doing some back end stuff, but I was doing both back end and front end. And then I joined another company where it was also back end and front end. But the way it works is the engineering manager will wake up in the morning, create all the tickets.
Yeah.
So 5 back end, maybe 5 front end to balance it. So I used to time when he wakes up. So once it's done, I'll go and take all the back end tickets and then do only back end alone. So only me will do all the back, and other people will be doing front end. And then sometimes he will notice and create only like 10 front end with no back end in it. So I'll message him and be like, please, I don't want to do like put back end tickets there. And now finally, like my team will not have front end at all. So I've not written front end like maybe 6-7 years or something. Wow. So if you're a back-end person out there, keep struggling. You get to a point where you never have to do any UI work again. So I'm living in heaven now because I used to dread change the color, like the screen size. It works on the laptop, it's not working on the phone. I don't want to do all those things. So the issue is most of the core business logic is at the back end. So you must do front end first. I've had issues on the back end where we gave out more money than we should. We lost more money because of like little mistakes that you make. So multiplying by 10, you multiply by 100 or something like that. So it's not, business terms is not funny. So they want you to at least prove yourself for a while, which is understandable before you end up doing any back end stuff. So that's how I got into it. But it's very possible, depending on the company as well, to just learn back end directly. It's just that with smaller companies, you will limit yourself if you want to do only backend alone. Like, especially if you're just starting out, take anything. The main thing is get a job, get into the space, start working with people.
Excuse me.
This is not time for you to be picky. Like, any job you see, you do it. Any end, you take the end, you do it, and then you grow from there. So,
That makes sense.
Yeah.
Did you have mentorship?
That's a very good question. For sure. I had mentors that I looked up to. So most of my mentorship is indirect. There are many people that have mentored me, they will never know me, or I don't know them. And it's just based on like, maybe books I've read and talks I've watched and what they've done. more of what I had, I would say, is like a community of people that are suffering with you. Like, one thing with a mentor is they've already done that thing. They don't really feel there's a disconnect. Like, you just keep pushing. But this one, two of you in the trenches together. Oh, I press your code. Did it work? Oh, your own didn't work. What of your own? My own worked. So I'll share your screen. Let me see. So there were people like Kezi, some, many of my friends that were all, we had one like, what was it called? I can't remember. There was a coding thing we used to do. You see like different scores, you have points, coder block or something. Like, oh, what's your point? Even till today, we have a group where it counts how many hours we've coded every week. So I'm like, oh, I'm last. Next week I have to go up. So there's nothing like just coding with people. Like, you can read any book, you can do. So you have to sit down, put your laptop, type it, let the other person see, run your own code, let the other person see. So yes, and also like going for events and stuff, meeting people that are also like trying to learn stuff as you, and just discovering that there are many other people out there that are like doing things. Yeah, so that just helps you learn. I won't really focus too much on like, there's just something about talking to people that have made it. You think that if I talk to this person, but you can't tell you anything interesting. Sometimes you're even not smart enough to have a discussion with them. So like, you can meet someone that, and you're just still so young in your journey, and they're like, oh, what server? You're like, which server? Me, I've not reached that level. So the discussion is not even interesting. Yes. So for you to get the most out of those kind of people, you need to know what you even want from them in the first place, because they don't have anything to tell you. Like, believe it or not, they are normal human beings that have just like, so there was a time, there was one very, very smart computer scientist in America. He's almost 18 now, or even already 80, Leslie Lamport. And I read many of his books, I read many of his papers. So I wrote him like one very big email. I was like, I've read this algorithm, will you do it? And just reply with no. And I was so happy with that. I screenshotted it, I put it on my Twitter. He replied me. So, okay, what did I learn from that reply? Nothing. But yeah, I was just like hyper fixated on like what that meant for me. So many times, being in the trenches with people is much more important. And
because I asked that question because a lot of people are quite fixated on mentorship. I want a mentor, I'm looking for a mentor. When like you pointed it out so succinctly, you cannot clearly articulate what you want out of this person. You are not at the level, which is not an insult, but it's sometimes just a fact to say your level of intelligence and their level of intelligence plus exposure are on two different levels. So when you come to the company, and most times it's also on them to sort of understand that this person probably has 2 years of experience or 1 year. So how I'm thinking is not how they are thinking. But people don't also have the capacity to sort of, for lack of that term, calm down. And so there is this gap.
Exactly.
And you are thinking Mars, they are thinking Venus. So it makes the whole conversation, the whole process quite fraught to deal with. But having people in your trenches with you is very, very important. I think because people are, I want a mentor. I don't know. It's like, it's not saying that people, you shouldn't walk around without, you shouldn't seek professional advice. I mean, you read books. We all read books. We did podcasts. We do blogs, everything. Indirect mentorship, but some people are still, a lot of young people sometimes are still waiting on that. I want the person to sit down with me every 2 weeks and have a conversation with me. Honey,
you might not find it. And like, it's a good thing, but it shouldn't be the main thing. Like, it should be maybe 10% of, I've done this, let me show. Am I going the right direction? These are the books I'm reading. Do they make sense? This is career choice I want to do. It's not like tell me what I want to or tell me what to do. It's more like these are the things I've done. Does it make sense? And they're like, okay, try doing this instead, that type of thing. So I think that's way nicer. I have had like actual mentorship. Udacity is like a teaching platform thing. It's like Udemy where like you can. So I have mentored there before, and that's how it is. Like the assignments on the course, people do it, and then they come and ask you like, this is what I've done. That's how mentor. Not like what do I do. Nobody has, because your mentors are working. They have other things. So you just do stuff and then ask them if what you're doing makes sense.
Okay, so the friend group you have.
Yes.
This is how many years after now you guys are still.
So we all went to university together. Some of us. So some people I have known them since like 2012. Some people we've attached along the way and we've like figured things out. But we've had like many groups. Like during COVID, we used to do like a Google Meet event where people would come. I would like share my screen, do backend, like teach, show them like what to do, how I'll do it. We used to do like some Mandela meetups. I did some in Port Harcourt. My friend Kezi did some in Abuja. I come to Abuja, we'll do meetups. Samuel, even so we've been doing meetups. like learning, try to figure things out for a very, very long time. Like you see your face on the banner sometimes, like, like, what did I even know?
How did I get here?
But you're just so excited when you learn something. You think you're telling people the whole world, and I can't wait to like tell people what you've learned. And yeah, but for me, I think blog posts just have a special place in my heart because with videos, it can be like you properly curate your thoughts in writing, like that just somewhere that just sticks. So I mostly just like do that now, like more like write articles, people to read and stuff. Yeah.
Off camera. I hope you don't understand half of what.
Exactly. Like I had like a work blog post and I sent to my mom and she was like, "I'm sure this means something." Yeah, like I don't know what has happened.
I don't know what happened here, but
congrats to you. Yeah, you done something. Your company think it matters. You think it matters. So that's all. I don't really care. Okay. So yeah.
Okay, 2 more questions are in my mind.
Okay.
One is around, I think we spoke about this, the fact that how tough it is it realistically backend engineering? Because there was a gender lens to that conversation, but I don't think I want to just bring that here to just save us some trouble. And then there's another one of what you think has sustained you in your journey till now.
Yeah.
So which one do you want to do first?
So let's do the first one.
Okay.
That's a tough question. I don't know how to. So I have seen like any profession, people doing like maybe accounting, people doing arts, people painting, coming to learn backend engineering. So it's nothing I would say, oh, if you didn't do science when you were in secondary school, it might be steeper then, yes. Like you might need to learn more things, yes, but it's the first thing is possible. But there are many variables in place, like, oh, how curious are you, or like how fast are you at learning stuff, all of that. So, but I think the main thing I really feel is like doing ends, front end, back end, can make you deviate from the point, especially if you're starting out. Like, just learn how to program anything, and that will really help you choose. Because how do you even really know you want to do backend engineering? Do you see? True. I mean, sometimes you can just feel like, but I've worked with many backend engineers, and some of the best ones are people that did front end before. Because they now know what the front end people need. I've suffered there. I know this what this person wants. So they are just way more, the way they think about things, they're like, oh, no. Let's not do the front end. We'll have to call this 3 times versus calling it only once. So you have the idea of doing it. So no experience is wasted. I won't really like focus, but just I want to be a programmer is the main thing I would focus on. Like, how do I learn to program things? And then, okay, do I want to do back end or front end? So I won't say it's more complex than doing front end. I would say if you want to be a back end person, it's the same way you want to be a front end, the same way I want to be an any end person. But the actual currency of any end is like learning how to program. So can you write a programming language? That's what you should figure out. No matter where it is, you can be write a calculator, it can be write. So just look for projects that actually teach you how to program, and that would matter anywhere. Like if tomorrow, God forbid, but they're like, oh, there's no more backend in the company, everybody, I will write if I won't say I'm not doing it again. And I can do it because I've done it before. The color might not be great. Maybe we need a designer to like look at it, but don't box yourself up so much that you think that's anything you want to do. But yeah, I mean, that's not a good answer because I didn't say how many months, how many weeks it will take, but it's hard to say, but it's possible and it's not more complex than, I won't say it's more complex than the front end. Like, I see what those front end people be doing and I'm like, this might actually be, need to be more these animations, things are moving around, I don't really know. So yes, it's just what you like. If you like it, no matter how hard it is, you like put in time to learn it. So
it's like somebody said it different. She said, "How bad do you want it?"
Exactly. So you want it. Yeah, you would figure it out.
Okay. Okay.
The second question was,
what has sustained you? What do you think has sustained you to this point? Because it gets hard. I think it gets. There are times where I've spoken to you at 8 o'clock. I'm on my laptop. What are you on your laptop?
Like, what are you doing?
For your 8 o'clock.
It's just very simply curiosity. And you also need to have that, like, you have to be very honest with yourself. Like, sometimes you're in a place you've become comfortable. You know you become comfortable, but you don't want to move on. Okay, you've like debited, it's okay. So you need to come to a place where you're like, okay, I've learned this thing so much. I need to go somewhere else. So I need to like learn more things. You don't need to ask yourself more questions. Like, you don't want to get too comfortable with the thing you already know. Like, there's something else I don't know about what this is happening. So like, I think that's just the main thing. I mean, you can be in one place and you're curious enough for there forever. There are people like that. So I'm not saying you must always like live where you are, but just be sure that you're not getting rusty. So you're not like stuck on the same things you already knew.
Yeah.
Learn a new language sometimes. Like most times, the hardest thing is moving from your first language to your second. Because be writing one. Once you know 2, you can know 10 because you already know how to like change your. So like read what other companies are doing. Like Netflix has some of the most amazing blog posts. Like Google has some of the most amazing. Like they have research papers from many years that you won't imagine it, like wealth of information you find there. So if you just go and read just one or sometimes it takes you days or even weeks to read those because they're very technical. But even the vocabulary you use, you know how like when somebody's like has read and you know how yeah. Sometimes you use and like I'll be like, okay, this person is so. Instead of saying CPU, there are some things some people say, oh, the computers, doesn't know that. What's the name? There's some interviewers want to hear you say the actual canonical name of something, and you can't really say it because you don't know what it is. So just be curious and be honest with yourself enough to know that I need to keep learning something. And no knowledge is wasted. Some things you learn now, you might never use it. Sometimes it might come up like many years later. Some things are just hobby things like, oh, okay, now I know all about Intel, and nobody asked me. I know too shop on my like my work review stuff. So, but you just know that these things are what keeps me curious, because if you're not curious, you won't really be productive, you won't really deliver, you won't really be happy at where you are. So curiosity is what like makes at least me like more passionate about whatever I'm doing, because I know that okay, I want to actually like learn this thing. So I think that's the major thing. Just be curious.
Stay curious. I think I'm going to start calling our listeners on this series curious, high curious people.
Is that what they said?
Yeah, I think that's because it's such a vital element, and sometimes you can't quantify it.
Yep.
But you can only see it in your actions, like reading about things that other people are doing.
Yeah.
I've seen the progress that's happening in the world.
Yeah.
And just opening your mind to the possibilities of what is out there.
Yeah.
Is there anything else that you want to add that you're like, oh, we should have thought about that, we didn't speak about that? Now is your chance to shine.
Not really. I think we have. You're a good host. So we have.
Did you hear that?
We have covered most things. I think, you've covered most things. The things you need to know: hardware, OS, programming languages, stay curious, how the interviews work, what community means. I think we've covered most. Any other thing now is just to get to technical or like things that don't really matter. But if you want to actually like steer your career in the right place, I think we have touched on enough to make people make the right choice.
I think this last question is just for I think this is going to be our last question in this series now moving forward.
Yeah.
If I am telling a 14-year-old who probably thinks they want to go into backend, I mean, they can probably change their mind in 7 months.
Yes.
What should they add there? Because you remember the English, maths, physics, chemistry.
Yeah.
What should they be taking seriously in school? Does it really matter? Does it link?
So, like there are all these quotes. Some people like take learning seriously. Like if you learn how to learn. There's all of that. So I may be biased because I like math. I just feel like math is just useful in everything.
I don't understand how you like math. I cannot.
And like there are some math particular topics I didn't really like in school. So like statistics, and like which is so useful, especially with like big companies with like data. So they're like, oh, what is the median? Like how long does your site load? What's the P50? And you're like, I don't really want to know this. So it's just more than coding, but math is just
fundamental.
Yeah. I just feel like.
And English as well.
Yeah.
And English. I mean, because fundamental, most of the popular languages in programming are written in English.
Exactly. So.
And then if you want to grow higher, you want to be able to communicate, you need to understand English.
Exactly. So. English and math.
Okay.
Which is a requirement for YX.
So yeah. Oh, don't remind me. Please, don't remind. I've never been so happy to see the end of an exam.
English and once your YX result comes out, English and math.
That's
the rest you can sort it out.
Right. That one. Yeah. Okay, thank you so much.
No problem. It was
Thank
nice
you so much
talking
for
to you,
doing this. There's a lot of the energy that went into this episode. Let's just leave that there. God the devil is the one that rewards you because.
Exactly.
But yeah, I actually learned a lot, and I hope for our listeners, our curious people, you actually took 1 or 2 away from this conversation. So I will see you whenever.
Yes.
Bye.